In June of 1816, snow began falling across parts of New England. Temperatures dropped below freezing, frost damaged corn and other crops, and farmers who replanted sometimes watched their new crops die again. The cold returned throughout the summer. Across the Atlantic, Europe was experiencing another version of the same disaster. Persistent rain damaged fields and grain harvests. Food prices climbed. In Switzerland, Germany, France, Britain, and Ireland, abnormal weather contributed to a major food crisis. 1816 would eventually become known as the year without a summer, but the people living through it had no idea what was causing it. The answer had begun thousands of miles away, more than a year earlier, with one of the most powerful volcanic eruptions in recorded history. The timing could hardly have been worse. Europe had just emerged from more than 2 decades of revolutionary and Napoleonic warfare. Napoleon had been defeated at Waterloo in June of 1815, but much of the continent faced economic disruption, unemployment, poverty, and food insecurity. Agriculture remained essential to survival, so a failed harvest could quickly become a humanitarian crisis. Grain became scarce and expensive, bread prices increased, hitting poor families hardest. In several regions, shortages contributed to protests and unrest. Switzerland suffered particularly severe conditions, with poor harvests and high prices pushing vulnerable communities toward hunger. This was no longer simply unusual weather. For many families, it became a struggle to find enough food. North America experienced the crisis differently. In New England and parts of eastern Canada, the problem was extreme cold. May brought damaging frost. Then, in early June, temperatures fell dramatically. Snow was reported in northern New England, ice formed in some places, and crops were destroyed. Farmers replanted, but more cold followed. The agricultural failures also contributed to migration from New England toward lands farther west. The weather was not the only cause, but another failed harvest gave struggling farming families another reason to leave. Europe, meanwhile, continued to suffer from rain and low temperatures. Climate reconstruction shows that 1816 was among the coldest years of the 19th century in parts of the northern hemisphere. Different regions experienced different combinations of cold, rain, frost, flooding, crop failures, and rising food prices. Moving food was also far more difficult than today. Railways barely existed, roads were slow, and long-distance transportation was expensive. When several regions suffered poor harvests simultaneously, replacing missing food became extremely difficult. And nobody understood why this was happening. There were no satellites, global weather networks, or climate models. A farmer in Vermont had no way of knowing that people in Switzerland were experiencing consequences of the same global event. The strange summer also became connected to literary history. Lord Byron spent part of 1816 near Lake Geneva with Percy Bysshe Shelley, Mary Godwin, later Mary Shelley, and physician John Polidori. Cold and wet weather repeatedly kept them indoors, where they challenged one another to write supernatural stories. Mary developed the idea that became Frankenstein, while Polidori later wrote The Vampire, an influential early vampire story. Byron also wrote Darkness, imagining a world where the sun had disappeared. But the real explanation for the strange weather began more than 11,000 kilometers away, on the Indonesian island of Sumbawa. In April of 1815, Mount Tambora erupted. On April 10th, the eruption entered its catastrophic phase. Explosions were heard hundreds of kilometers away. Ash rose high into the atmosphere. Pyroclastic flows devastated areas around the volcano, and communities were destroyed. Tens of thousands of people ultimately died from the eruption and the famine and disease that followed. Tambora reached level 7 on the Volcanic Explosivity Index. For comparison, the 1980 eruption of Mount St. Helens was level 5. Tambora's summit collapsed, creating a massive caldera roughly 6 kilometers across, but its influence did not end in Indonesia. The eruption injected enormous quantities of sulfur-containing gases into the atmosphere. These produced sulfate aerosols. tiny particles capable of reflecting some sunlight back into space. They spread through the stratosphere, reducing the amount of solar energy reaching Earth's surface and contributing to global cooling. More than a year after Tambora erupted, people thousands of kilometers away were living through its consequences. The snow in New England, failed harvests in Europe, and cold rain over Lake Geneva were connected to an eruption on the other side of the planet, and the worst consequences were still unfolding. By the summer of 1816, the strange weather was becoming something far more dangerous than an unusually cold season. Across Europe, harvests were failing at a time when millions of families depended on grain for survival. When the supply of grain fell, prices rose rapidly. In Britain, the crisis came during a period of economic hardship following the end of the Napoleonic Wars. Soldiers returned home looking for work, industries that had expanded during wartime slowed, and poor families were already struggling. Bad harvests made the situation worse. Bread, one of the most important foods in the working class diet, became increasingly expensive. Across parts of Germany, France, Switzerland, and Austria, the situation was even more severe. Heavy rain damaged grain and made harvesting difficult. Hay used to feed livestock became scarce. When farmers could no longer afford to feed their animals, some were forced to sell or slaughter them. Food shortages also encouraged speculation. Merchants and traders could hold grain while prices increased, creating anger among people who believed food was being kept away from them for profit. Markets became places of tension. In several regions, crowds protested high prices and demanded access to affordable grain. Switzerland experienced some of the worst suffering. Continuous rain and failed harvests caused severe shortages. Poor families searched for alternative foods, while local governments attempted to organize relief. Hunger weakened people and made communities more vulnerable to disease. But the crisis did not end when 1816 ended. The damaged harvest meant there was less food available during the following winter and spring. In many places, the first months of 1817 were even harder. Food prices remained extremely high, and the period became one of the last major subsistence crises in Western Europe. Ireland faced another danger. Cold and wet conditions damaged crops, while hunger and poverty helped disease spread. A major typhus epidemic developed during the crisis and killed thousands. The weather had not directly created the disease, but hunger, displacement, and weakened populations created conditions in which epidemics could become much more destructive. Across the Atlantic, farmers faced different choices. In New England, repeated frost and crop failures convinced some families that farming there had become too uncertain. Thousands were already moving west, and the crisis helped accelerate migration toward places such as western New York, Ohio, and Indiana, where land appeared more promising. Even animals became part of the crisis. When oats and other feed crops failed, keeping horses became more expensive. Horses were essential for transportation, farming, and moving goods, so rising feed prices affected more than individual farmers. The disaster revealed how vulnerable early 19th century society was to climate. A few degrees of cooling did not sound catastrophic on paper, but agriculture depended on narrow growing seasons. Frost at the wrong moment could destroy months of work. Too much rain could prevent grain from ripening or being harvested. One failed crop increased prices. Several failed crops across multiple regions could create hunger. And Tambora was not acting on a perfectly stable climate. The early 19th century was already part of a relatively cool period, and other volcanic eruptions had occurred during the years before Tambora. The enormous 1815 eruption added another powerful cooling influence to an already unusual climatic situation. For ordinary people, none of this was visible. They could see the rain. They could see frost covering fields in summer. They could watch food disappear from markets and prices climb, but they could not see the thin layer of volcanic aerosols high above them. They did not know that material released by a volcano thousands of kilometers away had spread through the atmosphere. For them, there was only one immediate question: how do you survive when the season that is supposed to feed you never arrives? While Europe and North America struggled with the consequences, the people living near Tambora had experienced something far worse. Before the eruption, communities lived on the slopes and around the base of the volcano on Sumbawa. Tambora was not simply an empty mountain. People farmed the surrounding land, traded with neighboring islands, and lived in settlements that had existed for generations. When the catastrophic eruption began on April 10, 1815, the destruction was immediate. Enormous columns of ash rose above the mountain. Pyroclastic flows, mixtures of superheated gas, ash, and volcanic debris, rushed down its slopes, destroying settlements in their path. Ash fell across a huge area. In places close to Tambora, it accumulated so heavily that buildings collapsed under its weight. Daylight disappeared as ash blocked the sun. The eruption was heard far beyond Sumbawa. British officials hundreds of kilometers away initially believed the explosions might be cannon fire, and sent forces to investigate. At sea, floating pumice created additional problems. Large fields of volcanic material covered parts of the surrounding waters and interfered with ships. But surviving the eruption itself did not mean surviving the disaster. Ash had buried agricultural land, crops were destroyed, water sources were contaminated, livestock died. Communities that depended on the next harvest suddenly had little food. Famine followed. Disease spread through weakened populations. People fled affected areas searching for food, putting additional pressure on neighboring communities. Modern estimates of the death toll vary, partly because records from the region were incomplete. Thousands died during the eruption itself, while tens of thousands more are believed to have died from starvation and disease in the months that followed. The physical transformation of Tambora was enormous. Before 1815, the mountain may have risen more than 4,000 meters above sea level. After the eruption, a large part of its summit was gone. In its place was a gigantic caldera, approximately 6 kilometers wide and more than a kilometer deep. The eruption expelled tens of cubic kilometers of volcanic material. It remains the largest known explosive volcanic eruption of the last several centuries. But ash alone was not responsible for the strange summer that followed. Most volcanic ash falls out of the atmosphere relatively quickly. The more important global effect came from sulfur dioxide released high into the atmosphere. There, it helped form sulfate aerosols. Unlike ordinary clouds or lower atmosphere pollution, these particles could remain in the stratosphere for months or years. They reflected a small percentage of incoming sunlight. The change sounds minor, but Earth's climate is sensitive to changes in incoming solar energy. Average global temperatures fell, while regional weather patterns shifted in complicated ways. Tambora did not make every location cold every day. Some regions experienced extreme rain, others experienced drought or unusual frost. The effects varied depending on location and season. Scientists today can reconstruct parts of this climate disruption using historical temperature records, written observations, tree rings, ice cores, and other evidence. People in 1816 had none of those tools. They could record what they saw, but they could not connect events separated by thousands of kilometers. A volcanic eruption in Indonesia, snow in New England, endless rain in Switzerland, crop failures in Germany, and hunger in Ireland appeared to be separate disasters. Only much later would scientists understand that they were pieces of a much larger climatic event, and the consequences of 1816 would leave traces that lasted long after the weather finally began to improve. By 1817, the weather was beginning to move toward more normal conditions. But for millions of people, the crisis was not over. The failed harvest of the previous year had left food supplies dangerously low. Grain prices remained high in many regions, and families that had exhausted their savings had little protection against another difficult season. In parts of Europe, 1817 became a year of continued hunger, disease, and economic hardship. Eventually, harvests improved and food prices began to fall. But a year without a summer had already changed lives. Some families had left their homes permanently. In North America, migration away from parts of New England continued as farmers searched for cheaper and more productive land farther west. In Europe, the crisis demonstrated how quickly poor harvests could turn economic hardship into social unrest. The strange summer also left cultural traces. Mary Shelley continued developing the story she had begun near Lake Geneva. Frankenstein was published anonymously in 1818 and became one of the most influential novels of the 19th century. John Polidori's The Vampire appeared the following year and helped shape the image of the aristocratic vampire that would influence later literature. Even the paintings of the period may preserve hints of what was happening in the atmosphere. Artists including J.M.W. Turner became famous for dramatic skies and intense sunsets. Volcanic aerosols can produce unusually vivid sunsets by changing how light passes through the atmosphere, although connecting individual paintings directly to Tambora requires caution. The scientific explanation came much later. During the 19th and 20th centuries, scientists gradually developed a clearer understanding of how major volcanic eruptions could affect climate. Evidence from temperature observations, ice cores, tree rings, and historical records eventually allowed researchers to reconstruct the effects of Tambora in far greater detail. The eruption became one of the clearest historical examples of volcanic forcing, the ability of a massive eruption to temporarily alter Earth's climate. And Tambora itself never disappeared. The volcano remains active today. Its enormous caldera still dominates the landscape of Sumbawa, a physical scar left by the 1815 eruption. For generations, much of the human story surrounding the mountain was poorly known. Archaeological investigations have since uncovered traces of settlements buried by the eruption, sometimes leading Tambora to be compared with Pompeii. But unlike Pompeii, Tambora's disaster did not remain local. Its effects crossed oceans. A farmer in New England losing his corn, a family in Switzerland struggling to buy bread, and writers watching rainfall over Lake Geneva had no reason to believe their experiences were connected. Yet high above them, the atmosphere had connected their worlds. That may be the most remarkable part of the year without a summer. The people of 1816 lived in a world without satellites, global forecasts, or instant communication. A catastrophe could happen on one side of the planet, alter the atmosphere, and begin affecting people thousands of kilometers away before they even knew the original event had occurred. Today, we can watch volcanic eruptions from space. Scientists can measure sulfur dioxide, track aerosol clouds, and model possible climatic effects. The people of 1816 had only what they could see outside their windows: rain that would not stop, frost arriving when crops should have been growing, snow falling in summer, and harvests that never came. For them, the cause was invisible, but thousands of kilometers away, the answer had been written into the remains of a mountain. Mount Tambora had erupted in 1815, and 1 year later summer disappeared.